Hello, my name is Robert Mays, and my wife Suzanne and I are NDE researchers. We have been doing research in NDEs and consciousness for the last 11 years, and we are pleased today to present some new insights that we have had about memory and consciousness. These insights come from the result of two recent studies of the special character of NDE memories. And the main objective of our research in general is to demonstrate the reality of the independent autonomous mind in ordinary consciousness. And the basis for our work is the evidence that comes from near-death experiences. You can read more about our research at our website, selfconsciousmind.com. So let's discuss what memory is to begin with. We distinguish three main types of memory. And so let's consider this diagram here of the underside of the brain. If you take out the brain from the top of the head like this and turn it around and hold it in your hand like this, then you will see this image of the bottom view of the brain. There are a number of structures of interest here for memory. To begin with, there's the hippocampus. There are two hippocampi, one on each side, and the medial surface of the temporal lobes. Now, the temporal lobes are these structures here and here, which are on the side of your head, just above your ears. And another important structure is the prefrontal cortex, which is right behind your forehead. And finally, there are the two hemispheres of the cerebellum. Now, all of these structures are important for memory. Episodic memory is the memory of experienced events, and it's connected with the hippocampus. Experienced events like you remember that you were in trigonometry class in grade 10, and Miss Baldwin was at the board, and she was drawing a diagram of a triangle on the board and labeling it and saying that this side is equal to this side, and that's an isosceles triangle. A triangle that has two sides that are equal. And you remember that experience, and that's an episodic memory. In contrast, there's semantic knowledge. And these, where we know math facts, including the fact of isosceles triangles and what they are from that lesson, but now it's a piece of knowledge, it's a fact. And semantic knowledge includes abstractions, facts, word meanings, personal facts of your own life, your own experience. All semantic knowledge is derived from episodic events. And where is semantic knowledge or semantic memory located? Well, neuroscience says that it appears to be connected globally with the brain. Don't have a specific place. And then the third type of memory is pattern memory. These are memories that you use to walk, to ride a bike, to have whatever patterns of movement, speech, any habit patterns like how you brush your teeth and so on, emotional patterns and so on. All of those patterns come about, and they're a form of memory, and they come about through repetition, and they're associated with the cerebellum. In animals, there's also instinctual behavior, which is are patterns of memory which appear to be inherited. And then finally, there's working memory, which is very short-term, almost like a memory sketch pad, what you can hold in your mind for maybe about 30 seconds, and this is associated with the prefrontal cortex. Now, there are two mysteries of memory. Where is memory formed and stored, and how is memory recalled? Well, where is memory formed and stored? There's a conventional view for episodic memory, at least, that it is the strengthening of neural connections called long-term potentiation. So that when you have an event in your life, that event occurs and activates circuits in your sensory, emotional, and prefrontal circuits, and those are imprinted or formed in and strengthen the connections in the memory storage in the hippocampus. So as you have experiences, activity throughout your brain, then those are all reflected in the hippocampus and strengthen the connections there. And that's what the storage of memory is, according to the current materialist view. And how is memory recalled in this view is that the strengthened neural connections allow memory to be brought back and repopulate the neural circuits from which they came, and those things are brought back to consciousness, and that's the memory. Now, this model does not explain the recall of semantic knowledge very well because there's no location for the memory. And of course, pattern memory is not studied as much, but the assumption is that it also works in a similar way in the cerebellum. Now, an important case when you're studying memory is the case of HM, or patient HM, Henry Molaison. He died in 2008. He suffered severe epileptic seizures as a child and went on to adulthood, and he would not be controlled by drugs. So in 1953, both the hippocampal structures were surgically removed. Now this helped a lot, his epilepsy, but unfortunately he could not form or recall episodic memories after that point. If he was distracted, he could never remember who you were, even if he had had many interactions with you over the years. Every encounter was completely new. So you would be talking to him, he would look away, he'd be distracted, and then he wouldn't know where you came from and who you were. This case and similar ones is the basis for associating the formation and recall of episodic memories with the hippocampus. Now, HM retained prior semantic knowledge. He had a very rich vocabulary. He did crossword puzzles all the time. He retained his math skills from high school and so on, but he could not form new semantic knowledge easily. There were 2 or 3 rare exceptions where he could form semantic knowledge, and those are telling because apparently they involved repetition of emotionally engaging content where we feel that the semantic knowledge was immediately formed rather than going through episodic memory and then being consolidated. So he knew of the assassination of JFK, he knew about Skylab as a satellite around the Earth, and he was very familiar with the TV show All in the Family, with Archie Bunker and Edith and Meathead. HM retained all other forms of memory, such as working memory. As long as he wasn't interrupted, he was able to hold on to things if he kept repeating them, and pattern memory. He could actually learn new skills. But episodic memory formation and recall are connected with the hippocampus, and new semantic knowledge requires episodic recall, so he had no episodic memory capability, and he thereby could not acquire new semantic knowledge. All right, so now we're going to talk a little bit, just to introduce near-death experiences. Near-death experience, NDE, is a profound psychological event that occurs generally when one is near death or in a state of extreme psychological or physical distress. And there are striking elements in the NDE. Feeling separated from the body, seeing events out of normal physical sight, having a view of one's life, a life review, seeing a beautiful heavenly realm when deceased relatives or spiritual beings. And those are some of the key elements of the Grayson NDE scale. And there are striking phenomenological aspects of NDEs that are relevant for our work with memory. NDErs have apparently non-physical veridical perceptions, or AVPs. Now, these are perceptions that are accurate and have been verified, perceptions of the physical environment. And they occur during coma or cardiac arrest, or when the NDEr could not have physically perceived them. Then these are apparently non-physical veridical perceptions. So that's one phenomenon. Another phenomenon is that NDErs report that their perceptions are hyper-real. So they really feel that what they have experienced is realer than this reality. And the memories, as a result, apparently, of the NDE are indelible. Generally, their memories are clear and unchanging even after decades after the experience. And when recalled, the NDEr feels as if they are reliving the experience, like in an altered state of consciousness. And there are numerous after effects. In particular, most NDErs feel that their experience was the most significant event of their life. So what's going on in NDEs? There are two opposing explanatory hypotheses to explain these effects. First, there's the brain production hypothesis that the electrical brain activity produces these effects. So one explanation is that the experience was imagined or constructed either before one went into coma or went into unconsciousness or immediately after coming out of unconsciousness. Or that they heard certain things afterwards and they constructed what happened. Another variation of this is that there are various physiological effects that produce hallucinations that are reported as NDEs. Lack of oxygen, endorphins, and various neurotransmitters are called into question there. Now, the second hypothesis is what we call the mind entity hypothesis, that the person's consciousness or mind has separated in some way from the body. The mind is thus a separate aspect of the person and is the seat of consciousness. So in ordinary consciousness, the mind is united with the body fully. And then during the NDE, the mind separates and operates independently of the physical body. And then after the NDEr comes back and they have been changed. There's apparent changes in the energetic field that seem to cause various after effects with electronics, sensitivities, and so on. Now, in talking about the special nature of memories of NDEs, when the NDEr is remembering their experience, there was a 2013 study by the researchers in the University of Liège, Mireille Tonard, Stephen Loris, and colleagues, and they looked at memories of NDEs that occurred during coma and compared those with memories that other people had who were in coma but did not have an NDE. So they compared the NDE memories of the NDErs with memories of real and imagined events in the non-NDErs. And they used a measurement tool called the Memory Characteristics Questionnaire, MCQ, that examined several memory characteristics, such as how many sensory details were present in the memory, how much the NDEr mentally relived the events, how much the NDEr remembered being involved in the event, and how much the NDEr felt the emotions of the event. And they found significantly more of these characteristics in NDE memories compared to imagined memories in the control group. The NDE memories had extremely high emotional content, were more vivid and real to the NDEr, even compared with memories of recent real events. And the NDEr remembered being involved in the NDE more than the non-NDEr coma subjects' imagined memory. So the conclusion these researchers came to was that NDEs cannot be considered as typical imagined event memories, NDE memories. The NDEr really perceived these phenomena. And this contradicts the skeptics' assertions that NDEs are dreamlike memories of events that never happened or are altered memories of real events that were partly or fully imagined. In contrast, the NDEr remembers being actively involved in the event. Now, there was a second study in 2014, Ariana Palmieri and Paula Sesa at the University of Padova, wanted to repeat the University of Liège study using the MCQ measurement tool. And they found that they got the same results. NDE memories had greater detail, richness, and complexity than imagined events. And there was no significant difference that they found between NDE memories and real memories. There was about the same amount of detail. But the researchers added 2 enhancements to the study. First, they used a hypnosis-based clinical protocol to improve recall and decrease inaccuracy for all the subjects. So the subjects, both the NDErs and the controls, were put into hypnosis and asked to remember a particular memory, the NDE, real memory, an imagined memory. And they also did EEG recordings to see whether the NDE memory recall has a significantly different EEG signature compared to the recall of real or imagined memories. Now, the MCQ score was evaluated before and after the hypnosis EEG session, and this gives a measure for the improvement in memory recall, which we call delta MCQ. In other words, they had a certain level of memory recall of their NDE before hypnosis. They go through hypnosis and they remember it, and it's more intense usually. And then after the hypnosis, they are measured again with the MCQ, and it's a higher score. And so here is the effect of hypnosis in this study. A significant increase in MCQ score for memories in all of the experimental conditions were found, and this was to be expected. More details will be remembered on hypnosis no matter what you're trying to remember. But the increase in the MCQ score was significantly higher for NDE and real memory recall than for imagined memory recall, and this is a further confirmation that NDEs are not imagined events. The EEG results suggest a qualitative difference in the brain in the way the NDE versus real memories are recalled, and this is quite unusual. So the NDE memory recall from their EEG study showed that there was, when the NDEr was remembering the NDE memory, there was low frequency in the frontal and temporal lobes, and low frequency meaning delta and theta frequencies of EEG. And then real memory recall was high frequency in the central and temporal involvement. So it was a different amount, or higher frequency, higher versus lower frequency, and different locations when a NDE memory is recalled versus a real memory. And this was a very important difference, and it is the basis of our model of memory. So how can the mind-entity hypothesis explain all of these facts? Well, the mind-entity hypothesis is that the mind can separate from the body as an energetic, non-material entity, and it's the seat of one's conscious experience. In ordinary consciousness, the mind interacts directly with physical processes in the brain, and there are a number of evidence that the mind does interact directly with physical processes, and they come from NDEs. There are interactions with physical processes in this out-of-body state, and there are other NDE phenomena that we pointed to in previous papers. And now I need to spend a little bit of time in the next several slides describing how the mind entity works with the brain, so that you have some idea how this, non-material energetic entity fits together with your brain and body in ordinary consciousness. So the first point is that the brain is a sophisticated mechanism used by the mind. And beyond that, the mind and brain have a closely coupled interface. So the mind is embodied in the brain and physical body. And you could think of this as like the embodiment that some drivers have with their car. And so they feel that their car is an extension of their physical body, and they can control the car, of course, with their own movements, but then they feel that when they control it, they're really controlling the movement of the car and not just steering something so that the car goes, but they're actually moving the car. And that kind of embodiment is really a shadow of the embodiment that we have of our mind with our physical body, because our mind is connected throughout the body. Wherever there are neurons, wherever there are nerve bundles, then our mind has a connection with that part of our body. Another point is that ordinary conscious awareness occurs only through brain activity. This is ordinary consciousness. You cannot be conscious unless your brain is active. If your brain stops, then you lose consciousness. Unless, of course, you have a near-death experience and you separate your mind from your body. But if your mind is united with your body and your brain isn't working, then you are unconscious. And another point is that there are neural connections, rather there are neural regions, this is well known, in the brain, and these are the Brodmann areas. So there is a visual area here, and there's a speech comprehension area here, there's a speech production area here, there is auditory senses here, and there's somatosensory senses here, and motor control here, and the executive functions in the prefrontal cortex. And therefore, the mind has to interface differently with each one of these different regions of the brain. So there's a different interface for the mind with the visual cortex than with the motor area or with the executive functions. And for our current area of concern, all memory content is located in the mind, not in the brain. So very briefly, how do we conceive of the interface with the mind at the detail level is as follows, very briefly, is that the mind interfaces with the brain at the cortical surface in the first couple of millimeters of the gray area of the surface of your brain via these structures here called apical dendrites of pyramidal neurons. And the mind interfaces through bundles of these, which are called functional columns, which are about a ½ millimeter across. And another point is that it takes electrical neural activity to build up to conscious awareness. This was a discovery by Benjamin Libet, an experimental psychologist, who did it through a number of experiments, and he called this the time-on principle. You have to have a certain amount of electrical activity for anything to come to awareness. So if you have a very mild stimulation on your skin, it's got to be, if it's just at the liminal, below the liminal level, you don't feel anything. If it's at the liminal level, it has to be going for ½ a second before you become aware, oh, something's bugging me here. And that's the time-on principle. And in our view, the mind is engaged throughout the process of coming to awareness. So as there is the beginning of the stimulus on your skin or through your retina, the mind is already engaged, but it takes 300 milliseconds, 500 milliseconds for it to come to full consciousness. And another important piece of evidence for the brain-mind interface comes from the phenomenon of ultra-rapid visual categorization. And this is the work of Simon Thorpe and colleagues at the University of Toulouse. For 20 years now they've been studying this. They present an image of a natural scene with or without an animal, and it is flashed for 20 milliseconds, which is 1/50th of a second. And the subjects can correctly say 94% of the time that the photo contains an animal or not. So even though it's so short, you can tell that there was an animal in there. And this is a very robust phenomenon with animals, faces, cars, etc., upright, inverted, color, or black and white. And the subjects report that they perceive a fully segmented scene in which the relations of all the objects in the image are clear. And segmented here means that the parts of the image have been separated out. So, to give you a flavor of this, we're going to do an example of one of these experiments. And we have to have a few caveats here because the picture selection that we had here of animals versus no animals was not very rigorous. And the precision of the timing is based on the hardware, and we've seen that sometimes the image does not show. So those won't count. So if you want to take part in this little exercise, get out a piece of paper to write on, and here's what's going to happen. And you don't have to do this, you can just watch. But there's going to be a blank screen for about 5 seconds, and then there will be a plus sign, which will last only 1 second, and then there will be the flash. So you've got to be looking when the plus sign is up. And you'll see a visual scene, and you'll have then 5 seconds to write down whether it was an animal or no animal, and then it goes on to the next test. Okay, so let's do this. Oops, this way. All right, and ready? Okay, here we go. Plus? Animal or no animal? Plus? Animal or no animal? Plus? Plus? Animal or no animal? Plus? It should. I'll just let it run. Okay. So here are the answers. I'll read across. Animal, animal, no animal. No animal, animal, no, no animal, animal, and no animal. So those who missed 2 or more, raise your hand. Couple. Well, the norm is that you will miss 1 out of 8. Anyway, you get a feeling for it. They flash, and you get a sense of it. You get a full picture. So what is going on in the EEG for the speed of sight, these rapid visual categorization? So we need to look at in detail the EEG results. With any stimulus, there is an evoked potential in the brain, which is the blip that is starting of the start of the stimulus. And in this case, the blip is right here. It's not very large. It's at 90 milliseconds. So there's been processing going on in the retina and so on, the visual cortex. Well, when it gets to the visual cortex, bim, you get this, and you get this blip everywhere in the brain. And when you're measuring something for the EEG, you're talking about hundreds of thousands of neurons are going off underneath one electrode. And it goes slightly positive. The image is shown, and the evoked potential occurs, and then there's event-related potentials, further electrical activity, that occurs all over the cortex. And what is shown here is what is happening in the front part of your brain for the first 375 milliseconds as the image comes to awareness. So after the initial potential, which is called P100 here, there is a follow-on of processing where the electrical activity goes down and it becomes more negative. That's okay, it's just a relative voltage. There's just less activity going on, and this is called the N100. And then after that initial voltage drop, there is a voltage increase called the P200, and it goes positive. And then there's a further N250, and then a P300 and something. So the dark line is the characteristic of the 15 subjects when they saw an image that had an animal, and they said it had an animal. They got it right. And the gray one is where the subjects saw that there was no animal and got that right. So this is when they saw an animal and it was right, and this is when they saw that there was no animal and that was right. And there's a difference, and the difference starts at 150 milliseconds. Now you'd think that if there was a difference, it would show up somewhere in the visual cortex, somewhere down here in the brain, or maybe at least in the parietal cortex where it's starting to be processed. You'd see some processing that says that's got an animal or doesn't. But what happens is that the difference shows up initially in the prefrontal cortex, the medial prefrontal cortex. So this is a plot of the difference. Okay, this is not all of the activity, it's just what's the difference between animal versus no animal. And you can see that in the first 125, almost 150 milliseconds, there is no difference. There's no distinction that could be made in the EEG between the animal and no animal distinctions. But at the 150 millisecond point, there is this difference that starts to show up in the medial prefrontal cortex. And it gets very large for the next 25 milliseconds, and then it starts moving around in the brain and goes down to the visual cortex, which you would expect it to be doing, but this is now where there's a distinction that's happening in the visual cortex. This is where there's a difference, and this is probably going into the left temporal lobe, which is where we have recognition of objects. So that's what's happening. There's conscious recognition. The question of the prefrontal cortex involvement is really puzzling to neuroscientists, but it provides an important clue to us. And the standard neuroscience interpretation of these results is that there's a type of feed-forward, that mechanism that starts at the visual cortex, which is where the visual input comes in from the retina. So there's the visual cortex, and then that feeds forward to maybe the parietal lobe or some other place, and there's, passing back and forth of the neural signals, and that gets more and more complicated, and then at the end, you have this fully segmented scene that shows up, and that is what is recognized. And where is this located? Well, they would think that it's in the prefrontal cortex. That would make some sense, but they don't really know. Anyway, there are difficulties with this view because it doesn't really fit the observed pattern of differentiation and coming to awareness. It also implies that the neural network needs to be trained to recognize animals, and yet this process, this phenomenon, works with totally novel images. So in our view, this is what's happening. It suggests that the segmented perceptual scene is immediately available to the mind as this semantic knowledge. What you see with your eyes, your mind also sees, in quotes, intuitively and recognizes. And the semantic knowledge then becomes reflected in the prefrontal cortex as electrical activity. That's the P200. And the electrical activity proceeds to other parts of the brain, and after another 200 milliseconds or so, which is Libet's time-on principle, it comes to conscious awareness. That's why we observe that there's prefrontal cortical involvement at the beginning. Now, the visual percept comes to awareness as a unity of semantic knowledge. Neuroscientists have long puzzled over how does the brain unify the entire visual perception. It's called the binding problem. And in our view, there is no binding problem because the unity is already there from the beginning here from the semantic knowledge. And further processing fills out the details of the percept. So we infer that this same mechanism of semantic knowledge feeding into the prefrontal cortex applies to the recall of all semantic knowledge. That's where semantic knowledge comes in. And semantic knowledge is introduced from the mind and is very quickly reflected in cortical electrical activity. So as soon as you get a burst of the insight, then there's a bunch of electrical activity in the prefrontal cortex that reflects that. And then ultimately the knowledge comes to consciousness. So I want to reinterpret Thorpe's EEG data in the light of the mind-brain interface. So, as I said, we observe an initial evoked potential and a drop in electrical activity that leads to a negative at 100 milliseconds, then a rise in electrical activity that starts about 125, and then there is this first distinction between animal and no animal, and we know that there's recognition going on there in the P200. So our interpretation of this is that the N100, and this is a plot borrowed from another study of similar phenomenon, and during the N100, the mind represses the electrical activity and it goes negative. This blue, it means negative, and red means it's positive. So at this point, at the N100, at the bottom of the N100, we have what we're presuming is this mental process that is repressing the electrical activity and impressing the semantic knowledge in the medial prefrontal cortex. And then during the N200, we have the electrical activity rising in the prefrontal cortex and going on to become to consciousness. And this seems to be a general process in the brain. The mind represses electrical activity, impresses conceptual content, which then causes electrical activity, which then goes on to figure in your conscious awareness that you just had a thought or an insight or you just saw an animal. And so it is important to consider both electrical inactivity as well as electrical activity to understand consciousness. So now, since we're talking about memory, we want to summarize our view of how the different forms of memory work between mind and brain. So in ordinary episodic memories, memories of high school trigonometry, they are formed as the events are experienced. And the brain electrical activity from various parts of the brain, from sensory, emotional, executive regions, activate structures in the hippocampus, and memories are formed from the hippocampal activity and transferred to the mind. And they're there, I don't know where they are physically, but they're there in the mind. And they are recalled back through the hippocampus and reactivate the hippocampal pathways, which is why you get long-term potentiation, and then repopulate the visual field, the auditory field, the fear that you had, etc., in the amygdala and so on. And the memories then come to consciousness. So how does semantic knowledge work? Well, semantic knowledge is formed through the consolidation of episodic memories through dreaming and recollection. So you have an episode, you remember trig class, or you had a dream about Ms. Baldwin, and you are now remembering isosceles triangles, and now you know what an isosceles triangle is. That has been consolidated here in your mind. And then the semantic knowledge resides in the mind and is recalled directly into the brain, probably in the prefrontal and temporal regions, where you sometimes seem to receive intuitions. And the recall of semantic knowledge of experiences can sometimes be mixed with a recall of episodic memories. So you remember fondly that what an isosceles triangle because you remember that lesson. And how do NDE memories work? And this is really the point, among other things. They are formed directly as OBE percepts occur. So out of the body you have percepts. You see things, and they form semantic knowledge directly outside the physical body. The memories of the NDE events are formed through this direct interaction with the mind and can be from physical sensations out of body or transphysical percepts or whatever you have experienced in the NDE. And they are imprinted directly in the mind. The events are felt as hyperreal, and the memories are vivid and indelible. You can see why they would be felt as hyperreal and indelible, because they are directly recorded. Memories are not stored as episodic memories and are not recalled through the hippocampus, which is why we would see a difference in the signature, neural signature of remembering an NDE versus remembering a real event. Okay, we would expect that the direct recall through the prefrontal cortex is more intense, as I mentioned, than the episodic recall. And that would also be why it leads to an altered state of consciousness. So now Suzanne is going to add a recent new perspective on our work.
From the EEG patterns in the rapid visual categorization, we see two simultaneous processes apparent in the brain. First, with the evoked potential, a bottom-up neural process of the percept forming in the visual cortex. And second, a top-down mental process in which the mind impresses in the prefrontal cortex the structure of the parts or segments of the image. Without this process, the elements of the image are indistinguishable. The concepts and percepts are woven together in other parts of the brain and come to awareness as recognition and knowledge after about 300 milliseconds. This idea is not new, that the mind provides the structured component to perception. More than 120 years ago, the philosopher and spiritual scientist Rudolf Steiner wrote his major work, The Philosophy of Freedom, based on his introspection and insights into the nature of thinking and perception. Rudolf Steiner's insights bear a striking similarity to the observations from the ultra-fast visual categorization. Rudolf Steiner's insight that was due to our unusual mental organization, the perceiver receives two aspects of reality in perception. One aspect from perceiving through the physical senses, and one from thinking through intuition. In Chapter 5 of The Philosophy of Freedom, Rudolf Steiner indicates the twofold nature of perception. Quote, "It is due to our mental organization that the outer world is given to us, at first without the corresponding concepts. Intuition adds that part of the reality, the concept, which is lacking in the percept." Unquote. The thinking human being then weaves the two together to arrive at recognition and knowledge. Quote, "From every real thing, the relevant elements come to us from two sides, from perceiving and from thinking. The act of knowing or cognition is the synthesis of percept and concept." Rudolf Steiner recognized that the mind needs to repress the brain activity so that the conceptual content can be given. Quote, "The essence which is active in thinking has a twofold function. First, thinking activity represses the activity of the human organization. Secondly, it replaces that activity with its own activity. The repression of the physical organization prepares the way for thinking to manifest." Unquote. We observe this process in the prefrontal cortex in Simone Thorpe's experiments, with the reduced electrical activity immediately after the evoked potential during the N100. This is followed immediately by electrical activity that distinguishes the content of the image. For example, animal or no animal, only 60 milliseconds after the evoked potential. In this view, the complex conceptual content that distinguishes the animal versus no animal in the image has appeared through thinking activity. The effect of one's thinking activity can be seen more easily when the concept is not readily available to us. For example, in a hidden image like this one. If you haven't seen this image before, it probably appears like a random collection of black and white shapes. The image has not been parsed into meaningful segments. Actually, there is an image of an animal in the picture. But until one's thinking can bring the unifying concept, the image remains unsegmented and unintelligible. Once the concept dawns on us, the concept instantly organizes the image. Then it becomes impossible not to see the animal in the image. Rudolf Steiner wrote, "Without the thinking, the world is a multiplicity of objects of equal value. Objects remain unintelligible to us until we have within ourselves the corresponding intuition, which adds that part of the reality which is lacking in the percept. Without the intuitions corresponding to the things, the full reality remains inaccessible." We can see that here with these hidden images. So it's reasonable that we come to perceive and know external reality through two faculties, sense perception and thinking. One faculty is physiological and the other is spiritual activity. All good theories provide explanatory power. The better the theory, the more explanatory power it has. To begin with, this theory explains nearly all aspects of NDEs, in the phenomenology in particular, especially with veridical perceptions and NDE memories. And this theory answers the general enigmas of consciousness. Our recent paper, just published in the Journal of Near-Death Studies, gives a summary of these points. There's the so-called hard problem of consciousness. How does brain electrical activity turn into subjective phenomenal experience? That's actually pretty easy, because the brain doesn't produce consciousness. The mind working with the brain is conscious. The binding problem. How do the elements of perception get unified as a whole picture? We've just shown how, through intuition, the mind gives the fully segmented picture of what is perceived through a top-down mental process. And ordinary memory is explained as located within the mind and not in the brain. And it's recalled from the mind through various neural mechanisms in the hippocampus, the prefrontal cortex, and the cerebellum. And there are a number of neurological anomalies which we believe we can explain with this model. In addition to the rapid categorization, there is the readiness potential, presentiment, split brain phenomena, and so on. We don't have time to go into any details on them. This concludes our presentation on the mystery of memory. Thank you for your attention and for your interest in this research.
Couple of questions.
In the cases of Alzheimer's and senility, why doesn't the mind take over where the brain begins to fail?
The mind is connected with the brain as long as the brain is operating. And there comes a time, and therefore it is usually that the The brain just peters out and the patient goes unconscious. But there are these times of terminal lucidity where there is whatever the process is, we think it is a kind of loosening of the mind from the brain. It's a kind of partial out-of-body experience maybe, where those faculties, they're still there, conscious, so to say, but they now have all of their faculties. And it's not can't be relying on the brain, because the brain is really sick, is really damaged with dementia particularly. And so that's, so there are cases like that, and that subject is being studied by Alexander Batyan and a number of other researchers in Europe.
I've seen cases like that in the hospital where suddenly someone is completely lucid, and you think to yourself, why can't this be enabled somehow for people whose brains have deteriorated?
Right. Well, the difficulty is that then either they go on to die, or they sink back down into their brain, and then they lose the capacity but the important thing, one important thing to remember, regardless of the behavior of the patient, the dementia patient, which can be rather nasty, is that the noetic person, the soul, the psyche of that person is still there, behind the disease. And this is Viktor Frankl's insight.
Right. Thanks.
Hi, thanks for your presentation.
Thank you.
I only kind of have I guess it's only half formulated in me, whatever I'm trying to ask here.
Go ahead.
I think the spiritual is intimately connected with the physical. Even the angels and spirits that are floating around in the room, whatnot, they even have physical manifestations, whether we necessarily see them or not. Maybe if we look hard enough, we will. But along with that, during an NDE, what are your thoughts on, well, I'm supposing here I have this model that, okay, the person or the spirit is experiencing something, that's the mind, the spirit experiencing, but yet there's also a physical trace left behind, because after they come back, they remember it, they recall it. What are your thoughts on how is that memory formed? Is it some sort of instantaneous thing that happens?
Yes. Yeah, so we mentioned that when you're out of the body in the NDE, then the memories are formed directly as semantic knowledge. And then that's then immediately available, particularly right after the NDE, because then the person is glowing. I mean, almost literally, sometimes literally glowing after the NDE, or they feel this tremendous love, and that love sometimes fades, sometimes lasts a long time, and they can call it back through meditation and other ways of remembering, recalling. But the memory is formed exactly at that time in the NDE.
And is there are there physical manifestations of this, such as, for example, I think they've said they've recorded spikes in activity. Maybe that's related, maybe it's not. But what are your thoughts on the measurement of this, if there has been any?
Yeah, that's still very, very controversial, and we are working on, particularly NDErs, their energy field, and healers in general, their energy field. We feel we can measure that. We still have to do the experiments, but there's a lot of anecdotal evidence that that energy field can expose photographic film or paper, and we're working on that.
Thank you.
Yeah, thank you. One more.
Just one other question regarding the terminal lucidity. I think I read in some of these publications by Grayson and others about a woman who had a stroke, for example, who actually sat up in bed and said her husband's name before she died. And as a neuroscientist, I'm thinking, I really would like to understand how even with a stroke you can move in those last moments of life.
Yes, exactly. So right. And we can only speculate on that, but we feel that there's some way that the mind can still somehow get past and get into the neural networks that control motor movement and speech and so on, and somehow they make it happen. But when they're in their normal demented state, then they can't do that.
So maybe you can add that to your model in the next publication. That would be great.
Oh yeah, okay, we'll do that. Thank you. All right. Thank you very much.